Welcome to the nervous system. Here we go. What we want to do is look at the three types of neurons, and you can identify, of course, unipolar has one extension, bipolar, two extensions, multipolar, multiple extensions, and so that's what we've got. Now, for unipolar, I want you to be sure you recognize it's afferent, and so I'll just put this up. Here we've got afferent, and of course, it's sensory. Afferent, of course, going into sensory as well. Bipolar, for this one, you've got rods and cones here, also afferent. And as we see, sensory as well. So those two, but this one multipolar. And for multipolar, this is going to be the motor neuron, and of course it's going to be efferent. And so I'm just going to put this on here. And so we've got motor and efferent. And we'll see this again when we do the spinal cord with the sensory and with the multipolar. What I want you to do is to recognize on here the dendrites. I'm sure that you're familiar with those. I'm going to put an arrow for the way the impulse is coming. Impulse coming like that. So it's coming in through the dendrites, going down to the axon terminals. Axon terminals, there's a synapse, that's where the neurotransmitter is going to be. I want you to look right here. Here's the cell body or cyton, and then Schwann cells. Schwann cells are going to have a space between them, and that's the node of Ranvier. And so you can see those on your diagram as well. Now for a node of Ranvier, why is it important? It allows the jumping, the saltatory conduction of the transmission of the impulse, speeds it up so that it can go 300 miles an hour. So this is important to have the myelination. What color is myelin? Well, it's white. It's a lipoprotein, and so we've got that. Schwann cells, there's also a covering that goes along here. And I'm just going to draw it on in orange, and hopefully it shows up. And so here we go. Now, I'll write it in black so it is visible. And there we've got endoneurium. Endo around one neuron. So around one neuron, we've got endo. As you look, you could see peri would be around a group of them. And then around an entire nerve, it's going to be the epineurium. If you take a second and just feel right here, there's the median nerve going through the carpal tunnel, and it would have epineurium around it. So now we've got the basic structures of the cells. We've got the axon terminals, the synapse, the dendrites, the cell body, and now the endoneurium. Now that is pretty basic, and so we've got that information. What I want to do now is to have you go to the nerve action potential, and so we're going to look at that. You've got some pictures in your book as well, and so let's get on to there. Now, what I want you to do right now is to recall what is the charge outside a cell. And hopefully you thought positive. And why was it positive? Because of sodium ions. What was the charge inside the cell? It was negative. And so when we look at this, we need to think of a neuron. And I'm just going to draw a basic neuron, just the extension of it as it goes out there. And so here we've got it right here. Now, it would continue on, but I want to have you look. Here I'm going to put positive charges. And all of those are sodium, they're lined on the outside, so it's positive outside. And that's what we're seeing here. Now, of course, it's negative inside, and for the inside, then there's phosphate and sulfate and negative proteins. So this is negative. but there is potassium in here. I'm going to put potassium right in the corner. And so maybe I'll just make that change so that you can see it better. And there we've got potassium. Now when we've got potassium, that's an important feature because we're going to see the change here in just a moment. What I want you to do right now is to take your thumb and index finger and bring them just barely together, just so that you can feel that you can feel your index finger. Take it apart and don't feel it, but when you try to put that so that you can feel it, what happened? There had to be sufficient stimulus that it actually made the sodium go in. If it didn't, then you didn't feel that. And so now we've got sodium going in. As sodium goes in, it changes the polarity to positive. And so then it's going to change this to positive, but then what will happen is potassium will start to leak out. And so this is now going out. What will it do? It will actually make it positive outside again. And so the sodium goes in, this changes to negative, potassium goes out, changes it back to positive. So that's what we're seeing. And this is going to continue down and make the transmission continue down the neuron. What does this have to do with our graph? So let's look at the graph and see what we have here. The charge that's here is a negative 70 millivolts. That's what we're seeing as a resting membrane potential. So here we've got negative 70 millivolts, and that is the resting resting membrane potential. That would be the negative that's inside here, and I'm just going to put negative charges right along here. So there we've got negative, here we've got negative, negative 70. Go back to when you tried to put your finger to feel the index finger against your thumb. It had to reach the threshold potential. If it didn't get to the negative 55, it will not go all the way. So this is going to be the threshold potential. So negative 55, it has to get there. It has to hit the threshold. It's all or none. Either it gets there and you feel your finger, or it doesn't get there